We'll start with a facing operation. So I'm going to use snap to all. It'll pick up any endpoints of line, intersections, and so forth. That's why they call it snap to all. I'm going to put my cursor at the top, right mouse click twice, and it's telling me that's at an X of 3 inches. So okay, so the first thing we need to do is tell it that we're going to make a facing pass. So that we do that by calling it a curve. It's just basically a place for the tool to follow. So I'm going to make a new curve, and I'm going to use a linear move, and we're going to start at Z0 at 3 inches. Now we're going to come down to X0. So that's our path. The next thing we do, if you look at the next step, is to turn. And you could choose a face profile or a profile. Really doesn't matter. So we'll use a face profile because of its name. So we'll just call it face. And you can select a variety of tools. Assign a tool number. The edge angle, you can see here in the graphics, it's just the leading edge. I mean, it could be 0 degrees, just as long as you know that the tool has clearance. The back side is actually kind of important if it's going to be hovering over a groove, because what we do is we adjust the tool path based on the shape of the insert. Your index locations so that the tool doesn't have to go to the home position in the machine if we set up your post processor for that. Cycle data. We want the tool to be on the left side. If I start my tool up here and I come down to center, I'm looking down, I want the tool on the left. So that's correct. The engage angle. If you click here, you can see where the start of the curve, this is at like a 45 degree, 90 degrees. At the start of your curve, you'd be coming on 90 degrees. So let's turn that up to 0. Your clearance is 100, so it's going to be 100 thousandths above the line and then come straight down. You can set your constant surface speeds, you can set units per revolution, we have units per minute, and so forth. Then you go to machining and you verify your tool path. You can show the tool if you want. You can even step it. You can go to machining and put it in step mode. Click verify, your insert shows up, and it withdraws and comes back to the start point. Next thing we'll do is we'll drill a hole. Again, if I put my cursor here, and because I'm not building a curve, I can left mouse click once, and it gives me 876 is the diameter here of the bore. So we're going to go to a curve. I want to tell it where we're drilling. We do support live tooling, so we want to tell it the new curve is a rapid move right on the face of the part right here. Go to your turn tab, and we have a drill operation. The depth, if I put my cursor here down in the lower right, it gives me the position of my cursor grab. So it's negative 3.5 inches. So our depth will go, let's go 4. And if you're pecking, you can have your first peck, second peck. Next, we're going to assign a drill. Now I could make my own library. I could add to the library. And 201, let's see, the drill diameter is 1/2 inch. So we're going to use that. That'll be tool 2. And of course we can set the offset to offset 2. If I go back up to the face, we want the offset to be tool 1, offset 1. We use that for cutter comp. Close, machining, and verify. I'm going to turn the step mode off. Our next step is to, well, let's do the bore. We can slide the operations up and down with the arrows on your keyboard. So we can do things out of order and then order them as we need to. So let's make a curve, and I could have labeled the name, and I'm going to use curve chain. It just means that it flows through the part. So if I were to click here, and over here, it just flows through all of the entities until it gets to the last click. Go to turn, and we select the bore. You can see the heavy yellow regions. That represents rough material. So we have a rough bore. Pick our tool, tool 3, offset 3, leave a finish allowance, depth per pass. I'm going to hit manual and calculate. So this is where it picks up the 0.76. So if I have the inner diameter as the bore diameter, I do not get any rough material. There's no rough material there. So I'm going to change that inner diameter to our drill size and verify. You can do a 3D preview at any point. Now to see the inside of the machining, we can go to machining, stock setup, show a 3/4 view. Now I can customize the stock. I can go in, and this is probably important for when we do the backside. We don't want an overhanging material. Of course, you'd have a bar stock, probably face it off. So we'll go to 3D stock curve, and it'll be a cylinder. The length, let's see, 10 inches. The diameter will go 3.125, and okay. I was a little off on my 10 inches there. That's 3.5. So let's go back in and edit that. There we go. Now we'll make our chamfer and come up to the end of the maximum OD. So we'll go to new curve, chain, and I want to pick this side of there's your center point. I want to start here and go this direction. So we start here and we come out to here. Now if I want to extend that line, I'm going to switch to a linear move. And what I'll do is I'll go in, right mouse click twice, and we're going to go in a negative direction, 0.25. So every field's a calculator, and that just brought that an extra 1/4 inch. So now we'll go to turn, rough turn, that was tool 1, offset 1. Now let's just show you this. If I go down, there's a spreadsheet. Keeps track of all your operations, all the tools you're using, how you're using the tool. You can modify these and it'll automatically update these. So I'm going back to tool 1, offset 1. Now I could set these parameters in the tool library, so when I select the tool, these will automatically be created. I'm just changing things on the fly. Now again, we need to go in manually, calculate, and we're going to add that 1/8 of an inch of rough stock and verify. Now we'll do a finish turn. So I'm going to leave curve 5 active. That's the active curve. So when I make a work step, it's automatically going to use the active curve. So I'll go to Profile. Same tool. We want this to be on the right side. Curve 5 starts here and goes out this direction. So when I'm standing looking down, I want the tool on the right. Take off our finish allowance. And verify. So now let's do a finish pass on our bore. Let me just look back here. So we're using tool 3, offset 3 for the bore. Make this curve my active curve. That's also going to be a profile. That will be on the left. Now we need to flip the part to the other side, and we're going to use a subspindle coordinate. Now, you may or may not have a subspindle. Doesn't matter. What we're doing is we're flipping the part around. So we're going to deactivate these just by right mouse clicking on them. I would have produced a program for that. And now we need to produce a program for the other side. So what we need to do is make our subspindle our active coordinate. So down here you have world. We're going to switch that over to subspindle and do a top view. And I'm going to take the subspindle and I'm going to move it 3.5 inches so it's on the face of the part. So we're going to go to Edit, Move, Z and X should be 0. And we're going to move to 3.5. Enter. Now I'm moving the subspindle, so over here in our list box it's in red. Click on it. Escape. And now we build our curve. Chain. And we're going to chain from here to here. That'll be a rough turn. We'll use tool 1, offset 1 again. Now the MCS ID, that's where we tell it we're using the subspindle. Let's take a look at that in 3D preview. Now if you want to see it all come together, right mouse click on these operations here, the previous ones. Preview again. So far we're on the right track. And maybe what I'll do, now let's look at the toolpath in the groove. It optimized for the contour, the shape of the insert. So it didn't violate that. If we go into the operation, you can see we have undercut checked. Let's click on that. You can see the graphics. There's the tip of the tool. Tip of the tool plunges into the groove. And there are cases where you'd use that. And we'll turn undercut check on. and it maximizes the path. Okay, the only thing that's left is the groove. So we'll make a new path. I'm going to use a linear move, snap to all, zoom right in here. We'll start here, come down, over and up. Go to a groove cycle. And we'll get a measurement. Let's take a measurement between here. And we're just going to use the check. I don't want to put an actual dimension on there, at least I don't. So we're going to go check distance. We're going to check from here over to here, and we're going to look at what the Z value is 188. So we'll go back to the groove, and we're going to choose a groove tool. We have to make sure our tool will go deep enough. You have to take into consideration it starts up here, has to go deep enough. So I'm going to use a long grooving tool, let's say 2 inches max depth. I know I'm not going to violate the part. This will be tool 4, offset 4. You can pick rough and finish and individual operations as well. We'll do both. The step over. If I set 100% and there was a radius on the tool, it would leave a little cusp in the bottom. So we're going to use an 80% step over and verify. Okay, that was a good example. The tool is actually on the wrong side of the curve. So we started here and we came down, so I want the tool on the left side. We go into the groove, you can see it's set for right. Verify again. So it's a good thing for graphics. Do a 3D preview. It's a nice looking part. Okay. And then maybe what we'll do is we'll put a threading operation on here. And we're going to go with curve, new curve, linear, starting here, ending here. Now I could have hid the other curves. They're all blue. So when I start here and click here, I'm going based on skill. I know that there's a curve underneath there. Maybe what you do is go to edit and blank, and you can blank all these curves here. They're still on the screen, they're still available, I just hid them. And then we would work with just that curve. So now we go to turn and thread. First step would be pick a threading tool. Now you have calculate or fixed. I can say I want 2 steps. It'll take 2 passes and it's done. And then you can add a spring pass where once it's at depth it goes through one more time just to clean up the threads. That could be 0 as well. We're going to go with calculate. You have a starting clearance, so you give your tool time enough to ramp up to speed. So you have your start and then you have the end, and we have to make sure the end clearance does not violate the part. So it was a 188 gap, so let's go with 0625. The lead is 1 divided by 6 threads per inch. The depth will be automatically calculated, and the depth is based on 0.65 times the lead. So you may come up with your own depths. Just bear that in mind. So we'll go with 20 thousandths there, and we'll take off the spring pass. Now the constant surface feed will be off, and assign an RPM. Okay, check our retract and engage angle. So let's go in here. Our engage angle should be anywhere from 1 degree to 90 degrees. And we'll go with 3125. Okay. Now just to go back a little bit, if I go to, I should have explained sub-spindle profile here. You can use cutter compensation, so it will take into consideration of the tip radius here. Now the tip radius can be 0, and you would have to tell it the radius in your control. If I tell it the radius in CAD-CAM, then you would only put a wear value of 1,000th or what have you in your register. So let's turn off our sub-spindle operations. You can do a verify all, and it gives you an overall machine time based on your feeds and speeds. It is taking constant surface feed into account. Then you go to the post, the G button, select your post processor. You can even use sequence numbers. There are some posts that aren't designed to use that. There's reasons for that. And you tell it where you're going to save the G-code file, and hit your post button. Some posts ask you to enter a program number. And now we have completed all of the operations, and we're ready to take that file to the machine, whether it be stored on a USB key, a PCM-CIA card, or an RS-232. We do support RS-232. You just check the EZDNC button, and a window comes up, and you can send them and receive the file. This concludes this video.